Hello and a warm welcome to everyone joining us today. I hope you're having a wonderful day so far. Today we will understand the networking and cybersecurity demands in the manufacturing sector during the digital transformation and how DDI solutions can resolve them. In this webinar, we'll explore the perspectives of DDI solutions of digital transformation towards the modern dynamic environment. We'll also deep dive into how DDI solutions benefits your organization by providing scalability, centralized and integral view, and enhanced security when implemented with policy-driven management and automation. A very quick introduction. I'm your host, Vikram Aditya, product expert from ManageEngine. I collaborate closely with the marketing teams for ManageEngine, DDI Central, and Cloud DNS. A big part of what I do is talk about the critical network services like DNS and DHCP and IPAM. I'm here to share the insights on how DDI solutions can significantly optimize manufacturing network infrastructures. As for the agenda today, firstly, we'll have an in-depth view of cyber threats and networking issues in the manufacturing sector by looking at the stats and figures. We'll then go through the modern networking demands of the manufacturing sector when they're looking forward to digital transformation, the major networking challenges they face when adapting digital tools. Next up, we'll discuss about how scalability and availability is achieved in your organization's network with the help of DDI solution. Then we'll see the importance of network segmentation for enhancing your organization's network security and how it benefits your network service when implemented. Moving on, we'll explore how policy-driven automation and management enhances your network operations effectively across multiple sites. After that, we'll talk about how the real-time analytics feature of DDI solutions help in maintain the security and efficiency by ensuring optimization of records. We'll then cover the essentials of DNS security and how to implement multi-layered strategies to protect your organization. In this bar chart, you can view that in 2020, manufacturing companies like electronics, automotive, industrial equipment, and pharmaceutical embraced the digital transformation to enhance their services, but faced a higher number of cyber threats and attacks, especially ransomware attack. Ransomware attack is the most common type of attack faced by the majority of manufacturing companies. A ransomware targeted IT systems of a manufacturing unit will proliferate across network boundaries and force the operators to shut down the OT, which will cost far more than they could pay to regain the access to the IT assets. A very good example would be the 2019 Locker Gogo ransomware attack against Norsk Hydro, a Norwegian aluminum parts manufacturer, which costed them $52 million in the first quarter of 2019. But these industries put forth efforts to implement tools and bring in different strategies to strengthen their network infrastructure from these oncoming threats. By that way, they have mitigated the damage caused. One of the many reasons for their success is the implementation of a DDI solution, DNS, DHCP, and IPAM, for protecting their network and troubleshooting issues and threats, which benefited them in their growth and development. Let's now focus on the demand of the manufacturing sector, which are crucial to ensure efficient, secure, and scalable operations when transforming to the digital. There are 7 key demands that the manufacturing sector needs to address for effective network management. Centralized platform for network management and configuration. A requirement for a unified system that provides administrators with a single interface to configure, monitor, and manage network devices and settings across an entire organization. A platform that could simplify troubleshooting and updates by providing a centralized point of control. Security, regulatory compliance, return on investment, and corporate trust. Implementing robust security measures and following regulatory standards protects sensitive data and ensures legal compliance, fostering corporate trust. Strong security and compliance infrastructure build customer and partner confidence in the company's reliability and trust. Business connectivity with multiple branches and offices. Establishing reliable and secure communication channels between geographically dispersed locations ensures seamless collaboration and data sharing. This connectivity is essential for unified business operations, enabling centralized control and resource sharing. Structured IP address plan with complete network visibility. Organizing and managing IP addresses systematically ensures that devices can be easily identified and managed within the network. Complete visibility into the network allows for effective monitoring, troubleshooting, and capacity planning. Monitor real-time network traffic for prioritizing and routing. Continuous observation of data flows within the network enables the identification of malicious intruders and optimization of traffic routing. It also aids in detecting security issues such as security breaches or network failures for prompt resolution. Managing a hybrid workplace for remote and in-office employees. Strategies and technologies that support seamless collaboration and access to resources for employees regardless of location. Balancing the needs of an in-office and remote workers involves maintaining consistent security policies and ensuring adequate support and communication channels. These challenges need to be addressed with the right IT solution, which benefits in building a secure and effective network management infrastructure and streamlining the network service for every organization to support their growth and development. This image is a holistic representation of how multiple manufacturing units are being interconnected using a private WAN backbone network. This network consists of multiple VLANs, LANs, private and public cloud infrastructure, and data centers to link a private WAN. Manufacturing sector during their digital transformation will find it difficult to administrate an integrated network infrastructure and also to safeguard network resources. As you can see, the network centralizes and connects several manufacturing sites, enabling employees to connect with the site's network from their remote location. This involves a high-performance private WAN serving as a backbone. The backbone is often established using dedicated IP MPLS routes or an optical core that interconnects all the part of the network with transmission devices, while branches connected to it are connected via SD-WAN, SDN, or IP MPLS augmented via VPN. The main challenge faced by this network infrastructure is the converging of all the sites under a common IP infrastructure. How do we achieve IP convergence here? A network infrastructure like this needs a convergence solution like DDI. Let's explore what it is. DDI is a specialized network management solution that provides a centralized monitoring and administrating console for the three core network services, DNS, DHCP, and IPAM. It enables you to take complete control and gain a holistic view into the configurations and activities of those services. With the DDI solution, you can easily define and manage scopes, dynamically assign IP address to hosts, set up custom DHCP fingerprinting policies, manage DNS zones, views, and records, set up DNS security policies, analyze DNS query traffic, review audit logs, manage dual stack IP address inventories of your network, all in a single window. ManageEngine has its own DDI solution called ManageEngine DDI Central. It is a user-friendly, specialized solution that unifies DNS, DHCP, and IPAM into a single platform for improving operational efficiency and network stability. It manages your existing Linux-based ISC bind 9 and ISC DHCP installations and can also set up new clusters. It can also manage your Microsoft Windows DNS and DHCP clusters. Throughout this webinar, you will see its tools and features being highlighted to witness a DDI solution in action. To add it up, DDI solution, a one-window solution, acts as a single point of administration for all the different manufacturing sites or plants network. With DDI, you can manage the three core network services, DNS, DHCP, and IPAM, and their configurations to the remote sites connected with the main manufacturing network with technologies like SD-WAN, IP-MPLS core via VPN, or even dark fiber cables. As you onboard all your DNS and DHCP servers of a branch as a cluster into DDI Central, It starts discovering all the configurations in smaller divisions to firm them, facilitating a clear visibility. With all the configurations organized in its UI, you can easily control your core network services and take necessary actions. Analyze the visual analytics that accompany each module to get quick visual snapshots to arrive at a valuable, actionable insights that guides you with quick troubleshooting. This way, the main manufacturing network administrators can holistically view and centrally manage the core network services of different remote sites and are associated with the main plant, all from a single window. With a centralized network management across multiple manufacturing sites, your administrators can add the DNS and DHCP servers of each plant as separate clusters and manage their on-premise network facility. And they can also discover the configurations and manage all of them via a single window. This also enables you to monitor the health of the core service and scale the facilities in each clusters. Let's now focus on the crucial defensive strategy in network management, network segmentation. This adds another layer of protection, splitting the enterprise network into manageable and secure segments to reduce the attack space, limit data exfiltration, and reduce scopes of audits and compliance. Network admins can separate servers and endpoint devices based on the line of manufacturing they belong to. The implementation of OT network segmentation involves safeguarding the industrial control systems from the oncoming cyber attacks and meeting industry-specific regulations by separating sensitive data. So there is a need for the robust network security during the time of convergence between IT and OT. Administrators can separate the OT and IT by creating zones for different control systems like PLCs, HMIs, and SCADA systems to prevent malware and unauthorized issues. Segmentation provides a detailed visibility into each segment, its inventory, objectives, and policies in the form of DHCP options and tighter control over the configurations. This granularity is critical for identifying and responding to suspicious activities quickly. Network segmentation guides your network administrators where to look at in an event of incident or capacity exhaustion. In the event of a security breach, segmentation helps contain the impact over a limited area, preventing the spread of harmful effects across the entire network. Advanced scope monitoring with defined segments provide network administrators with a visual breakdown of IP addresses within the scope based on the availability status, capacity thresholds, ensuring effective capacity planning and resource optimization. Custom policies for address pools within the subnet allows for security and access policies tailored to the needs of different host groups within the same department, ensuring both security and operational efficiency. Segmentation also offers flexible configuration options for each scope, which means networks can be tailored to meet specific functional requirements or regulatory compliance needs. By grouping different subnets into shared networks, we can club multiple non-consecutive and unrelated scopes and treat them as a single entity to apply custom policies collectively. You can reduce the scope of compliance by reporting the audits of only those segments to the regulators instead of the whole network. Every manufacturing unit will have multiple devices and machines to be operated and moderated by manually or automation. For that, IP leasing is important. In order to prevent network overlapping and IP conflict, multiple devices in the plant will be segmented to different individual sections. This process is called network segmentation. The segmentation can be easily done with what's called DHCP Scope Manager in DDI Central, where administrators can segment, organize in hierarchy, and combine into one large network. Let's see how segmentation is done in DDI Central. Here in DDI Central, you can create subnets with a specific pool range for specific devices and machines in your manufacturing sector, like industrial robots, conveyor belts, testing machines, and etc., which helps in segmenting different departments without overlapping. You can also create static subnets of different pool ranges to ensure leasing is done for specific defined devices and prevent DHCP from leasing for general uses. This is a way to separate from other subnets and providing a specific purpose for leasing. You can also add different subnets with different pool range into a single supernet for administrators to organize multiple subnets in a hierarchical method for an easy visual breakdown. Administrators can combine multiple different subnets and define configurations with DHCP options or custom options with the help of shared network. You can categorize certain subnets to be under a virtual LAN with VLAN and describe their purpose. You can assign fixed IPs for critical devices with the help of DHCP's host reservation. And it's important to note that SuperNet and VLAN helps in organizing subnets to make administrations simplified, and there will be no configurations available for both of them. When the configured subnets are viewed under the IPAM module in DDI Central, the entire IP address inventory within the particular subnet is listed. As you delve deeper into a specific subnet in IPAM, a donut plot provides the visual breakdown of the number of IP addresses in the subnet according to their availability status. These visual snapshots assist administrators with effective capacity planning and alert them at utilization thresholds. In the event of an IP address conflict within a particular subnet, the admin can click on any available or free IP and directly assign it as a fixed address to one of the conflicting hosts until subsequent remediation. This way, administrators can have hands-on control over the IP address inventory within a subnet. On this slide, we have a simplified example of how network segmentation is achieved using DNS domain views. We'll walk through the process step by step, highlighting the distinction between internal and external views for zones under the domain name zilkerindustries.com. So let's see what are DNS views first. DNS views is a special feature through which you can implement network segmentation using DNS domain views. It enhances protection against potential threats by customizing DNS responses, enforcing distinct security policies, and controls access for different groups and network segments within your manufacturing sites. Say a client is sending a query for the domain name zilkerindustries.com. The request is sent to the DNS server to resolve the domain name into an IP address. Upon receiving the query, the DNS server first checks the client's IP against the internal view match list. The internal view match list contains only IP addresses of registered employees in industry. Since the client's IP is not in the internal view, the DNS server then checks the external view. The external view has no such IP restrictions and resolves queries for any client IP. This view is used for provide a version of zilkerindustries.com that only offers generic information to external visitors inquiring about Zilker Industries. The DNS server confirms that the query for zilkerindustries.com should be handled under the external view. It locates the requested zone under the domain name zilkerindustries.com and directs the client to the appropriate resource. The IP address returned by the external view is different from the internal one, ensuring that only public, non-sensitive information is accessed. Finally, the DNS server sends the appropriate response back to the client. The client then proceeds to access the resource. You can analyze the queries to the views configured along with the hosted and non-hosted domains. Alongside, you can have a visual breakdown over the number of queries to the views and domains for a custom time interval and number of queries received per IP with the help of domain query analytics. To thoroughly evaluate a domain or view's performance, we'll select a specific domain or view from the list. This will display the domain-specific performance metrics, including hourly query load over a user-defined time frame. You'll also see details for IP addresses leased under this domain, such as lease duration, MAC addresses identifying each host, and vendors of each host machines. Additionally, the total query load across all IPs as well as the individual query loads are visually represented in a donut chart accessible by selecting the respective IP. Furthermore, a separate donut chart provides a visual breakdown of the query volume for different types of DNS records, illustrating the distribution for each query type. Clicking on the record type such as A or Quad A will display a comprehensive list of all the zones queried for the specific record type. This list includes the key performance indicators such as hourly query load, queries per second, and the total number of queries covering the zones associated with the selected record type. Additionally, you can select a specific zone within the record type to drill down and view a visual summary of the query analytics pertaining to that zone's records. DDI Central will continuously log all sections done and changes made in the DNS zones, records, and views, while also in DHCP scopes for providing insights to administrators to ensure no external alterations made to the confidential data in compliance with NIST CFS ISO IEC 27001, GDPR, and more. Let's see how DDI Central implements auto failover setups for DNS and DHCP services. In DDI Central for the DHCP servers, while configuring a subnet, you can add one primary and add as many secondary servers. In case the primary DHCP server fails, the DNS server comes to the fore and handles the traffic. If you want these servers to split the load, you can enter the relevant value in the split field. A value of 128 here indicates a 50-50 load balancing actively involving both primary and secondary servers to handle the DHCP traffic. For the DNS servers, while configuring a domain name, you can add multiple primary DNS servers for that domain name. Subsequently, DDI Central also accepts a list of multiple secondary servers to facilitate reliable access to resources across manufacturing network. With the DDI solution in place, data from all three core network services are not only collected but also correlated and analyzed in one central hub. In a DDI solution like DDI Central, IPAM serves as the centralized and contextualized network source of truth that maps upstream relationships among the core services. As you can see in the image, behind the lease history of a particular IP, you get to see how it has been captured and correlated rich IP metadata like DNS records, DHCP lease information, and IP address allocations of various hosts within the network. This unified approach allows for a holistic view of network operations, enabling manufacturing plant network admins to make timely and informed decisions based on the comprehensive data analysis. This information aids in quickly troubleshooting networking issues, optimizing resource allocation, and maintaining network stability. With these three core services integrated, DDI serves as a sophisticated automation hub as it becomes easy to set up end-to-end automation involving these services. So here are some of the key processes that can be automated using a DDI solution. Using DHCP server, you can automatically assign IP addresses to hosts on the network. This enhances the efficiency of network resource management and ensures that IP addresses are utilized properly, reducing outage and preventing address exhaustion. The dynamic DNS feature updates the DNS records automatically when an IP address changes, ensuring that the network resources are accessible via their host names. This is a crucial insight settings where device mobility and configuration changes are frequent, necessitating real-time updates. DDI systems automatically detect and resolve IP conflicts and maintain an updated IP address inventory, ensuring reliable connectivity and preventing downtime inside operations. Scheduled creation of DHCP scopes and DNS records allow network administrators to go on schedule it and forget it mode, enabling them to plan and implement network expansion or updates at predetermined time for maintaining uninterrupted service during operational hours. Scheduled DNS or DHCP report from the time to time gives admins a real-time snapshot of subnet capacities and zone query analytics for strategic resource planning of resources. DDI Solution offer built-in automated failover setups for DNS and DHCP servers, guarantee business continuity in the event of infrastructure failure in the manufacturing networks. DDI Central's DNS query resolution policies for Windows Microsoft servers help in configuring query responses and redirecting queries to the specific network segments based on the criteria such as time, Internet Protocol, and Transfer Protocol. DDI Central's Windows Microsoft enables you to configure DNS responses for different applications or services by defining the zone scope and also implement split brain configurations where you can separate responses for internal and external queries. This helps administrators manage the network traffic and segment the responses for different departments of the organization. This also helps in preventing DNS-based attacks such as DDoS, DNS amplification, and more. You can configure the QRP in Windows Microsoft by going into the DNS firewall and selecting the DNS QRP. Here you can create your own QRP by clicking Add QRP and provide the details in the fields such as name, criteria, condition for matching and not matching. DDI Central's policy-driven automation plays a crucial role in implementing specific configurations to selective devices in the manufacturing network environment. You can define policies for leasing dynamic IPs to selective machinery in a network segment by identifying the device type with DHCP fingerprinting. You can also deploy firmware and OS files into the devices in your manufacturing unit by identifying the architecture type with Pixie template. You can define policies for devices which you can choose to combine into selective IP address space or separated from the IP address pool by identifying the MAC address with client class. You can define the client class to provide specific DHCP options by configuring and implementing DHCP options. You can also define domain names for selective devices in your manufacturing plant network for easy identification and implement with DNS for dynamic IP address assigning with the help of DNS management. All these are possible with the help of policy-driven automation in DDI Central. DDI solutions like DDI Central benefits administrators in identifying the device's type and its MAC address from the DHCP request for categorizing in a client class with the help of DHCP fingerprinting. You can detect the device's type and classify it to a specific client class by creating a client class and providing the architecture or hardware details. This can be simplified with the template type where you can fill in the fields with details, but when it comes to the ISC format, you will have to provide the traditional ISC code. This helps in proper IP allocation and device configuration with policies by segregated devices based on their type. Plus, implementing by toggling, you can easily import the values from the pre-boot execution environment Pixie template to a client class to quickly distribute essential boot files based on the device OS type identification. This image illustrates a potential cyber threat attack within a manufacturing sector's network environment triggered by malicious PDFs and insecure emails and unsafe browsing practices. The manufacturing company has implemented separate firewalls for different individual plants, requiring administrators to manage and monitor each one separately, which is a tedious task when trying to protect each environment from the external threats. By using a DDI solution like DDI Central, you can implement a comprehensive multi-layered DNS firewall and manage all the environments from a single interface. As DNS is the first point of contact across external networks, the DNS firewall constitutes the network's first line of defense. Following a layered approach, it imparts self-defending capabilities to networks by placing strategic defenses against unwanted intrusions. It actively blocks malicious activity during domain map blocking and mitigates ongoing attacks with its response rate limiting policies. So let's see how DNS firewall works. DNS firewall's response policy zones in DDI Solution allows you to customize the responses for recognizable domain name by implementing security measures such as blocking malicious domains, redirecting users to safer page, and also applying custom policies. Query sent to the RPC domains is further analyzed by DDI Central based on the configured RPC policies. And when it matches the RPC policy, the query will be resolved to custom IP address, and if it doesn't match, it gets blocked and user gets redirected. You can enable RPC by selecting the domain type when new domain is created. An RPC can be created in the DNS options by selecting on response policy. The RPC also logs the queries to block domains, providing valuable insights into attempted access to harmful sites and helping to identify patterns of malicious activity. DDI Central enables you to apply a variety of DNS options to RPCs to have a granular control over the clients accessing it. Let's consider a scenario where a site worker has clicked a link with a crafty phishing email and unknowingly gets his or her system infected by malware. Upon connecting to your plant's private network, the malware tries to covertly access malicious sites using your DNS resolver. DDI Central easily manages such situations with its DNS firewall. This firewall maintains a blacklist comprising a recognized collection of undesirable domains. Before the resolver can provide the actual IP address, it checks the domain against this blacklist. If there's a match on the blacklist, the resolver does not proceed to fetch the real IP address from the external authoritative DNS server. Instead of connecting to the malicious site, the user is redirected to a safety page. By clicking on the DNS firewall in config section, you can provide the domain name to be blocked, category for blocking, and also the redirection IP to redirect clients to safer page. You can also view the domains blocked and domains blocked among the subdomains here. This data can be imported as CSV format, and you can also view the blacklist of malicious domains here with their categories. With the analytics page, you can identify which host is violating policies and accessing malicious sites from your network and also from what time. Administrators can be alerted about any form of security breaches and understand the trends in policy violation. Let's dissect a common cyber threat attack scenario involving a botnet and discuss the defensive strategies that can be employed using a DDI solution. At the core, we have a botnet command center targeting a particular victim network in your site's network. It keeps sending instructions to be compromised endpoints called botnets. These botnets then execute the attacks by sending malicious queries to the DNS servers using the IP address of the victim. This is known as IP spoofing. The DNS servers in your plant network, unaware of the deception, respond to these queries. However, due to the nature of the attack, these responses are not just simple replies. These are massively amplified, meaning a small query triggers a larger response. The final target on this onslaught is the victim network in your manufacturing plant facility. The amplified response floods the victim's network, potentially overwhelming it with data and causing significant disruption. This type of attack is known as distributed denial of service or DDoS attack. These threats can be instantly identified using DDI Central's query analytics tool that visually charts unusual spikes in hourly traffic, indicating a DDoS attack in progress. Now let's see how response rate limiting. To mitigate the DDoS attacks, DNS servers can be configured to limit the response rate to any individual IP address. This way, it prevents the DNS servers from being used as amplifiers in DDoS attacks and further prevent the movement of malware from compromised end-user systems to more sensitive systems, and data center resources. The response rate limiting is a DNS security feature that intelligently regulates response throttling to mitigate the impact of DNS amplification attacks, ensuring uninterrupted access for legitimate clients and upholding a well-balanced approach to security. It facilitates a selective response mechanism that ensures your network is not only resilient against attacks, but also remain efficient and reliable for legitimate users. Now let's see how response rate limiting RRL, which is crucial for controlling DNS responses, especially during amplification attacks, is implemented in DDI Central. This feature allows administrators to set various parameters that control different aspects of DNS response behavior. The RRL form that you see on screen does not just limit the number of identical responses per second from a single IP address or subnet, but also limits the number of all kinds of responses, error responses, DNS referral responses, specific types of DNS responses per second. You can also define how broadly rate limiting is applied across IP address ranges. It also enables you to specify the trusted clients that are exempt from rate limiting. By configuring these options, administrators can significantly reduce the impact of DNS-based amplification attacks, ensuring a more secure and reliable network. Response rate limiting can be accessed in IEC bind by selecting rate limit in DNS options, which provides several fields to fill in details, like R per second, errors per second, prefix length for IPv4 and IPv6, and more. You can provide the IP address of your clients you want to exceed from this list in the XM clients field. By selecting DNS RRL in configuration section in Windows, you can able to modify the DNS RRL settings by editing the values for your needs. You can also provide the IP address of clients you want to exit from this list in the XM clients list section. Cyber attackers need to move freely through a network to identify items of value. Network segmentation is a critical element of an overall cybersecurity strategy that reduces the risk of and impact of attacks during the occurrence of a breach. By segmenting a network into subnets or scopes, you isolate each segment from the rest of the network. Each segment establishes an isolated broadcast domain with the DHCP server. By taking this pragmatic approach, manufacturing units can minimize business disruption and reap benefits, such as limited exposure after an intrusion and reductions in lost productivity and remediation costs and reputational damage from the actual loss of confidential data. Network segmentation is only a part of DDI Solutions' layered security philosophy, enabling plans to survive intrusions and minimize or even prevent successful data breaches. In the end, this allows for a speedy return to business as usual. Segmenting the scopes into subnets and VLANs help contain the damage caused by isolating the affected segment, allowing administrators to more effectively cause the spread and mitigate risks. Subnetting also reduces network-wide threats by quarantining compromised areas and hindering authorized lateral movement within the network. Alternative way of working from a remote location due to the impact of COVID-19 created a demand among many industries, including the manufacturing industries, where employees demand access to work from remote location. Manufacturing sector now have enabled machines like industrial robots, conveyor belt systems, automated guided vehicles, AGVs, supervisory control and data acquisition, SCADA systems to be operated by operators from remote locations, which will be convenient and safety for complicated tasks. Despite adopting a hybrid workplace environment, it is crucial to secure the network of the manufacturing unit to ensure only workers are allowed to access confidential resources and prevent covert access to the network. In that case, expanding the network across different remote locations will make the boundaries vulnerable for attackers to breach in and cause damage to the infrastructure. To solve this problem, DDI Solutions provide the client class feature where the administrators can configure the client class type that programs for the DHCP server to recognize the client device and allow only authorized workers to enter the network. Let's say there are 10 workers who are in charge of operating industrial robots from their remote location. The client class will be defined to identify the MAC address of those 10 workers and allow them to get IP leased. And let's say one of them is stuck with a certain operation and needs support from his team. He can invite one of the members in the group of 10 to collaborate with him, which can also be done with the help of the client class. As we conclude today's webinar, let's focus on the key insight. DNS, DHCP, and IPAM are the cornerstones of network connectivity and operations. Integrating these into a full-stack DDI management solution not only addresses critical network challenges, but also future-proofs your network. A full-stack DDI solution consolidates all essential tools into a single interface, streamlining network administrators and enhancing efficiency. While some plans use freeware or open source DNS and DHCP server software or manage networks with spreadsheets, these approaches often lack the robustness needed for complex configurations. A full-stack DDI management solution eliminates these costs and frees admins from routine tasks, allowing holistic visibility and centralized management across distributed sites. DDI solutions synchronize security, management, and operational efficiency, safeguarding manufacturing networks from cyber threats. As cyber threats evolve, DDI's importance in site networks will grow, making it a crucial component of digital infrastructure. In the era of rapid digital transformation in the manufacturing sector, embracing DDI solutions is more than a technological investment. It marks a manufacturing unit's commitment towards delivering high-quality, flexible, and reliable network services that internal employees expect. Thank you everyone for joining us in this insightful webinar on how DDI solution can help in digital transformation for manufacturing sector.